All right, welcome to the help video for Scott's workout. All right, so the first assigned problem is number 4. So we are looking to, read the instructions, evaluate the equation for the indicated function values. So we're going to zoom in just a little bit. There we go. Evaluate the equation for the given value. So f of n equals negative n. So whatever our input is, whatever n is, we're actually going to just make it negative. So if we input negative 6, the output of that would just be positive 6. Right? So pretty straightforward. This is a function that just changes the sign of the input. So if the input's negative, it becomes positive, and if it's positive, it becomes negative. So we will move on. Next assigned problem is 7. Let me make sure of that before we go back to 7. Let's go check. Okay, yes, 5 and 6 are not assigned. There we go. Again, 7. F of n equals 10 to the n. All right, so we're going to take 10 and raise it to the n. Now, if it's negative 2, raising it to the negative 2 actually means sort of multiplying it by itself negative 2 times. But that doesn't really make any sense. What we did talk about is that when an exponent is negative, you can think of it as dividing instead of multiplying. So 10 to the negative 2, right? This is like saying 10 to the negative 2, right? That is like saying 10, well, actually, I guess it's like saying we have some number 1, and we actually divide it by 10 twice. Divide by 10, and then divide by 10. Oh, that's not what I wanted. There we go. Divide by 10 again. You could also think of this as being, oh, it's negative, which makes it a fraction. So now instead of being 10 times 10, it's actually 1 over 10 times 1 over 10. Either way, we will end up with 1 over 100, which is the same as 0.01. So either one of these solutions, right, you can have it in fraction form or decimal form, both are correct. Both are correct. Unless a problem asks you specifically to put it as a decimal or as a fraction, you can do either one if they are exactly the same. All right, set. Oh, I'm drawing. I didn't mean to be drawing. Oh, sometimes it doesn't let me back out. There we go. All right, the first number is n equals 1, not n equals 0. That's good to know. All right, find the next 3 terms in each sequence, identify the common difference, write a recursive function and an explicit function for each sequence. All right, good to know that the first number is n equals 1. All right, so what are the next 3? So this is 3 to 7 is up 4, to 11 is up 4, up 4, up 4. Okay, so 19, that says 19. 19 would then become, if we go up 4, 23. Up 4 more would be 27. And up 4 more would be 31. The common difference we just said was up 4, up 4, up 4. So plus 4 is our common difference. Our recursive function, so we're going to say that f of n minus 1, that's the fancy way of writing the previous, hang on, we want now equals in terms of previous, so we're not going to start with that. We will include it, but we're not going to start with it. So f of n, there we go, f of n equals f of n minus 1, so the current equals the previous plus 4, right? And then we also have to say, what is our starting point? We know that f of 1 equals 3. Oh, f of 1 equals 3. So we also need to know that the starting point, right, when n equals 1, we have 3 to start out. And our explicit function, so we are going to have, well, what would our starting point be? That's like if we plug in 0. So we're jumping up by 4 each time. So we're definitely going to have f of n equals, and we're definitely going to say we don't really know where we start yet, but we know that we're jumping by 4 each time. So 4n. And then where are we starting? Well, if our first step takes us to 3, and that's 4 higher than the actual starting value, then we should have -1 as our start point, because then if we add 4 for our first step, then we should actually get just 3. All right, so that'll work. What is next? So that's our explicit function. Oh, drawing again. Okay, we are moving. All right, done with this page. We're on to the next page. All right, question 12. 72 is where we start. Then we go to 60, then 48, then 36, then 24. Now, if you don't recognize that these are all multiples of 12, that's okay. You can just see the common difference. If we're going from 72 down to 60, from 72 down to 60 is -12, and then 60 to 48 is -12, and then -12, -12. Okay, so the common difference is going to be -12, which means our next values, from 24, we would go down to 12. Oh, that did not write a 12 for me. Let's try that one again. From 24, we'd go down to 12, and then we'd be at 0, and then we'd be at -12. All right. Our recursive function, so our current, or our f of n, is going to be the previous f of n minus 1 minus 12. Whatever our previous was, we take away 12, and that's the current state. And then we should also note that f of 1 equals, what was our starting value? 72. Okay. And our explicit function, okay, we're going to have f of n equals, now we're going down 12 each time, so it's definitely going to be -12n, because that's what our step is, -12n, and we'll change this up so that it looks more like an n and not an h, -12n. But what do we start at? Well, if our first step takes us to 72, then we actually would need to start sort of 12 above that. So if we plug in 1, we get 72. So this needs to be plus 84. There we go. All right, on to the go. Olaf is a mountain climber. The graph shows Olaf's elevation on the mountain beginning at noon and proceeding from there on. Use the information in the graph to answer the following questions. Well, the graph is not actually here. Sorry, we'll zoom in again. The graph is not actually here, but it is on the next page. So let's go over to the next page. Oh, let's go over to the next page. Here's our graph, and let's make sure that it is small enough to see. Oh, there we go. All right. So here's our graph. Our first question, what was Olaf's elevation at noon? All right, so noon, we'll do this one in, we'll look at this one in green. So noon, it's asking about 12 p.m. here. That is noon. So what was his elevation? Well, at 12 p.m., that's sort of like on this line here, right? We'd have to go all the way up and find that his elevation, it looks like, was right at 9,000 feet. So we're going to write that. And we will zoom out just a little bit more so we can sort of see more that's going on here. So we have 9,000 feet for this first question. 9,000 feet. It's always important to, well, first, Make sure your F's and your T's don't look the same. So, oh, that didn't look like anything. Let's try that one more time. 9,000 feet. There we go. Those don't look the same. But it's always important to put your units on because units will actually tell you sort of if you're looking at vertical or like are you looking at height or are you looking at time. If I just put 9,000, that could be a time of day, I suppose, 9,000 seconds maybe. But it's important. Like elevation, we're measuring in feet, so important to put our units. What was his elevation at 3 p.m.? Well, we're going to change colors on this one. We'll do this one in purple. So his elevation at 3 p.m. Let's do 3 p.m. here. Right? So we're going to look what dot is above 3 p.m. and it looks like it's right here. That looks to be just about halfway, right, between 4 and 5,000. So we'll call this 4,500. 4,500 feet, because it's still asking about elevation. All right, we'll go down just a little bit. How many feet had Olaf descended? Descended means gone down. All right, so how many feet had Olaf descended from noon until 3 p.m.? Well, we said that he was at 9,000 feet at noon. We'll do this in a different color, right? If he was 9,000 feet at noon, and then he went down to 4,500 feet at 3 p.m., how many feet would he have gone down? Well, we could just do that as 9,000 minus 4,500, right? That's going to give the total number. That's going to give the difference in feet, and then we just have to make sure that it's right. He is going down from 9,000 to 4,500. So 9,000 minus 4,500 is equal to 4,500. So the answer for 15, how many feet? It's 4,500 feet. So actually our answers to 14 and 15 are the same, but for 14, that's his elevation at 3 p.m. And for 15, that's how many feet of elevation he had descended in 3 hours. So same answer, but with different meanings. So that's important to take note of as well. And our last question of this assignment, does the value of f of n represent, well, the light turned off. It does that. But that's okay. We'll just keep working in the dark. Does the value of f of n represent the time or the elevation? Okay. So let's go back and look. F of n. Does it say? It doesn't tell us there. But if we look at the graph, f of n, we always were told that like our ordered pair, our point would be x comma y or n comma f of n. So if f of n is after the comma, that means it's the y. And if we look at the y-axis here, it's the axis we started to mark in green, right? This is our y-axis. It looks like we are measuring feet vertically. So if we go back to our question, right, does the value of f of n represent time or elevation? Well, f of n was the vertical, so f of n is elevation. Right? And something that's good to remember often is that n, or whatever the thing we're counting, that's known as our independent variable. That's more sciencey, but usually we're going to have time on the x-axis, right? So if there's ever time, it's probably on the x-axis, which means it's probably the input. So our output in this case is elevation, because that's a thing that changes over time. And that wraps up this homework help.